So hi everyone. We're going to be discussing a very specific problem that's limiting what our space is capable of doing. So that problem is, how do contracts go beyond tokens, right? Contracts right now are used for tokenization. The smart contract, scripting languages and networks like Ethereum are mainly used to generate and move around tokens. But the reality is that there's a lot more functionality in terms of what smart contracts could be doing. And that functionality essentially depends on those contracts having access to data. But the fundamental problem is that smart contracts right now on basically all the public and private chains, they cannot access data feeds. So this effectively means that smart contracts can't know about market events for financial products. They can't know about insurance, IoT data for insurance products. They can't know about shipment, delivery, or a bunch of other really important points for trade finance products. So essentially, until smart contracts can effectively talk to market data, events data, and different types of payments, they're going to be relegated to tokenization. And the point at which smart contracts can use data feeds to know what's going on in the real world and to affect real world events of value is the point when we go beyond tokens and into a whole new world of decentralized finance, decentralized insurance, decentralized trade finance. And in reality, this fundamental problem called the Oracle problem, or the smart contract connectivity problem, is at the core of why decentralized finance, decentralized insurance, decentralized trade finance aren't nearly as far ahead as they could be. So just to put this in a historical context, where we all started out back in 2009 and then into 2011, we had multi-signature functionality in Bitcoin. So this was the feature set that you had to work with. Then in around 12 and 13, you had protocol opcode-based smart contracts appear. So this means if you wanted a smart contract that did something other than multi-signature, you had to go to the developer of the protocol and you had to get them to manually update their protocol. Then you had a shift from this tedious process of adding another piece to the protocol the one that you wanted to use, to scriptable smart contracts. So scriptable smart contracts are a very big step forward in our space, and a lot of the credit for that goes to Ethereum, and they've done a great job of moving the space from it takes literally months to maybe even a year to get a smart contract into a protocol and get it working, to down to days or now even hours to script up a piece of smart contract code that runs on decentralized infrastructure. So the next significant shift, in our opinion, is the shift from these scriptable smart contracts that focus on tokens to scriptable smart contracts that are connected to all the market data, events data, payments capabilities, and essentially scriptable contracts that can be written about events and scriptable contracts that can make events happen. Because once again, until we get to the point where that's possible, we're going to be stuck in a world where smart contracts today, they cannot talk to data feeds, right? They cannot know that a market price changed. They cannot know what the Bitcoin price is for a Bitcoin derivative. They cannot know that an insurance event happened from an IoT data feed. All of these inputs about something actually happening in the real world are inaccessible to them. So then the question becomes, how do we solve this significant problem that's holding back what our space can, the large amount of value that our space can provide? Essentially, the answer is blockchain middleware. So what you need is middleware that connects external data feeds, external payment services, and also various blockchains to core smart contract code. So essentially, you need to generate the connectivity that would allow smart contracts to do more than tokenization, right? That would allow the smart contract to know about market events, IoT events, trade finance events, and that's how you get past this problem. Now, once you're getting past this problem, you want to be sure of a few key points. One key point is that you value the smart contract because it's reliable, right? The value of a smart contract is it's the most reliable. Oh, that's a big difference. Sorry. Okay, maybe I should have been doing that from the beginning. you value the smart contract because it's the most reliable form of digital agreement, right? There's no other form of digital agreement that provides the same guarantee that something will happen in the contract, right? So if I own a private key and I have a Bitcoin attached to that private key, that's it. I own that Bitcoin and it's extremely reliable, extremely deterministic. That same value is the value of smart contracts for more complex use cases. And if we want that value to actually exist for these more complex contracts, we need to make sure that that value extends to how they're triggered and how they settle, right? So like lead architects, CIOs, people that actually deal with billions of dollars in contract value on a digital agreement kind of level, they care if the whole system is secure. It's not as important that a part of it is secure and then another critical part is insecure. So if we want to expand the functionality of smart contracts outwards to more external events, more spheres of value, we need to also make sure that as we add that capability, that the overall reliability of the smart contract remains high. If the reliability plummets, nobody's going to put real value into these complex contracts. So this presents a fundamental challenge of how do we expand all the inputs and all the outputs that smart contracts can be connected to, and how do we maintain their reliability at the same time. Now, the fundamental way to look at this is to just examine how we wouldn't want to do it and then the approaches to solve this problem. So the way we wouldn't want to approach this problem is we wouldn't want to have a single centralized oracle, because that oracle is very easy to take out, right? The value of a smart contract is based on the fact that it has high redundancy, and that's why we trust the state change, and that's why we trust that that contract is highly reliable. Now, it doesn't make sense that you value that piece of the contract and then you have it triggered by a single centralized node. Your reliability just went through the floor, right? So this model doesn't, in the logic of our space, this model fundamentally doesn't seem to work. The very simple logical solution to that is just the way you have decentralization and you gain reliability from decentralization by having multiple nodes processing contract code, you can have that same level of decentralization at the oracle level. So at this oracle mechanism level of, I need to reliably verify an input in order to make sure my contract is reliably triggered, and then you can also decentralize the various inputs into the contract. A simple example, just to put this in more context, would be, let's say I have payment for delivery of some goods, and my contract is really reliable and really efficient, and it's going to automatically execute and generate and have payment happen. So I probably want multiple data sources, multiple pieces of information proving that delivery happened if I can have that happen. And then once I want to pay, I need market price data. And I probably want to make sure that that market price data is highly reliable, because the reliability of that data will determine if I'm accurately paying for the goods I received. And then I want to make sure that I'm able to pay in the relevant formats. So all of this input of critical data about contractual events, input of data about making sure the contract pays properly, and output of relevant payment methods is all something that a good piece of blockchain middleware would do. So the fundamental goal of our body of work at Chainlink is the generation of this middleware in a way that is secure and reliable, and also provides a multitude of inputs, right? So a large multitude of inputs being available to developers will increase the velocity at which they can build, right? The speed at which developers can build today is very low, because if they want to connect to a data feed, like if they want to build something like an Uber and they want GPS data and they want to send an SMS message and they want to do payments, if they try to build that in today's environment, they can write the core code, but then getting connected to all the relevant services to actually have an application that provides value can take weeks, months, probably longer. And so the other big value of having a good, the first gating issue is secure middleware, and then the second issue is how do you create an abundance of building blocks, of inputs and outputs that people can combine with their core code. And in combining that with their core code, they're now able to build a greater amount of applications. It essentially massively expands what developers can build, right? Like what happened in our space so far? We went from Bitcoin multi-signature to like some early version of colored coins, to a scriptable token-based system. And the second the scriptable token-based system became good enough, the second that feature set was actually usable, people generated a bunch of tokens, right? So all the capabilities became available, and people generated billions of dollars in value on these systems, and that's what happened, right? So logically speaking, the next step in the evolution is, if you look at the features that blockchain-based contracts, smart contracts, would benefit from, the next set of features will also create another generation of contracts, right? As you give developers capabilities to build more things, if they can actually build them, they then build them, and some of them live and succeed, right? So in our opinion, the next big stage in the development of our space is one where developers go from, I've just built a token and I've moved it around, to maybe I've built a smart security, right, that reacts to market data. Maybe I've built a derivative. Maybe I've built a decentralized insurance product or a trade finance product. And because I've been able to build it in days instead of months, I'm able to iterate, and I'm able to actually get a product out that people use. And once our space gets there, that's when the amount of value that our space generates goes from just tokens to all the forms of digital agreement, right? Because right now, the fundamental issue is that if you go to a bank or an insurance company, as we very often do, and you talk to them about smart contracts, you're competing against centralized digital agreements. And centralized digital agreements, they can talk to data, and they can send payments however the user wants. And they have this, they don't have the reliability feature set that we value, but they have this other feature set of being able to react to events and generate valuable events, right? So that means that in reality, we as a space, as a technology, win on one dimension to a very large degree, but then there's another dimension that's a gating issue for usage for these more complex use cases. And we have to win on both. So we're already winning on the reliability as a digital agreement, and I think once we start also winning, or at least having parity with affecting relevant value and reacting to value out in the real world, then the amount of contracts that are generated about topics other than tokens that'll just go vertical. Because now finally, just the way tokenization went vertical when the features arrived, this will also go vertical. Now there's a few other points about how you use trusted execution environments and how that overlaps with decentralization, but I'm not sure we have exactly enough time for those. So I think the core idea to keep in mind is that there is a very important issue here of how do we get the space from tokenization to all the other digital agreement types that house trillions of dollars in value. In our opinion, the answer is you need developers to be able to build those agreements, and then those agreements will exist on our space's infrastructure, and that depends essentially on those agreements having the relevant inputs and outputs. So I think maybe that's the core idea where we'll stop at this point. I don't know, is there time for questions? No time? Just one question, if there is a question. Yep, just.
What do you do to ensure the reliability of the oracles?
Right, so the question is, what do we do to ensure, I repeat the question now, I finally learned that lesson. What do we do to ensure the reliability of the oracles? So there's two sides to it. One is decentralization, and then another one is trusted execution environments. So we use something called Town Crier. So Town Crier uses Intel SGX, and then these trusted execution environments have a whole bunch of positive properties around confidentiality and reliability. And essentially, what they can do is they can even do things like generate highly reliable randomness. And so there's really two trust models. The first trust model is decentralization, and then the second trust model is trusted execution environments like Intel SGX. I think one of the unique properties of our approach is that we don't myopically focus on one or the other. At the core, we have decentralization, but then on top of that, we layer on things like trusted execution environments. And what that leads you to is it leads you to a system where if you want to consume highly reliable data using multiple approaches, You can do that, you can consume those approaches like trusted execution environments, but then the real benefit is you can consume it in a decentralized way. So those are the two main approaches. And then on top of those approaches, there's things like zero knowledge, and then beyond that, in a very early stage of research, is like homomorphic encryption. So the right answer is if you're making a secure middleware, you want a defense in depth approach, where you apply multiple layers of security. For us, those layers are decentralization, then trusted execution environments, and then we're looking at 2 or 3 other layers that can be applied as the research gets there. Does that? Great. Okay. Wonderful. So I guess thank you very much.